Balanced binary tree. It is given a binary tree where you need to determine if it is height balanced or not. Okay, so height balance means the difference should be one maximum. So if the difference is more than one, we cannot say it is height balanced. So it is a binary tree in which left and right set tree of every node. It is saying every, so we cannot decide only by looking at the root. So every node. So if it is this one, if we look from the tree, the root, and then if it is the left side and the right side not different smaller ones, we cannot say it is a height balance. We need to check every node. Okay, so this if we see this XML1, if we look at from 3, left depth is the depth of the left side and then the right side. The left side is 1 and then the right side is 2. So if we got a difference value 2 minus 1 or 1 minus 2, so it is just one difference. So it is no more than 1. So we can say it is height balance. But when we go down 20, left side 1, right side 1, so it is also height balance. This one 0 0, this 0 0 0 0. Every node has height balance. So we can say this tree is height balance. So if we look at the XML2, if we looking at 3, there was 1, there was a 1. On the left side is 1, on the right side is 1. So we can say 3, 4 for this part is height balance. And then what about this one? Different is just 1, so we can say this one is height balance. But when we look at from the 1, this one is 3, and then the right side is just 1. So the difference is 3 minus 1 equal 2. It is more than 1. So we cannot say that tree is not, that tree is height balance. We cannot say that, right? So if we go down from the top to the right to the left, so we have to go down again. So we will see 3, and then we will look at 9, and then 20, 50, right? And then when we go after 3, okay, if 3 is height balance, okay, we will see from another row, another node, right? 9, we will see another again, it's chimed. Okay, when it's come to the 20, we will go down again. So it is taking a lot of times, and then I think it almost go to the order n square times. So it is big O of n square. So we can we reduce to order of n? We can do it, I think, because instead of going from top to the left, we will move to the left to the root pad. So we will go to the left and then if 7 and 50 are high balance, we will go again and then hey 20, left side and right side, your left side, and also this one is 50 is also high balance, 7 is high balance, so 20 is balance. So we'll go at that again. So 9 0 0, so hey, I am high balance, left side is balance, oh, the right side is also balance, so we're different that. So this balance, this height, we only need the height of the leaves, height of the no, the depth, what is that? The depth or the height, right? So we need only the height of the chain nodes. So if we have, okay, now 15, we have 0 0, right? So 15 height is just 1, 7 is 1, 1 1, so 20 is plus 1, so 20 height is 20 no height is 2, 9 height is 9, no 9's height is 1. So we difference 1 minus 2, we will get the absolute value. If it is not greater than 1, we will say it is height balance. So by doing that way, I will call my help of function too. So but for the base case, if not like a base case, because we not use the recursive one, this one is just checking if the root is null, we will say hey, there's nothing, so we can say it is height balance. We will simply return true. So if it is not, we will go and check the height. So left side is 1, right side is 2, we will get the maximum value, and now we will plus 1, 3, right? So, okay, we will get height for the helper function. So we will return integer value because we will return height. So, okay, so now we will pass the root. Now the root is 3, right? So we will get the left side height and right side height. Okay, what if there is nothing? So we will check if root equal. Now yes, this one is a recursive, so we need to check that again. We will return 0, height is 0. Okay, so if there is 2, we will compare and then we will get the maximum value. So, but if we compare, if it is great, the difference is greater than 1, we will say this one is not balanced. So they have to know to the end, right, to the root. So we will have to return that specific value if it is not balanced. So I will like put let -1 for NBALANCED balance. Okay, so if we can use like a method APS values, like to get the absolute value. So we need to add some reference. So I don't want to do that. So I will do by myself. APS value means, okay, we will compare left height minus right height. If it is less than 0, it means we need to change the direction not to get the minus value. Else, we just simply return like that value. If greater than 1, we will simply return a -1. It is not balanced. So if it is not balanced, we will simply -1. So if it is not greater than 1, we will check which one is the maximum, right? If they now 9 and this one is 2, right? So if we see this one, maximum value of node 3 is, we can say it is 2 because we just got the maximum value of churns. So if left is greater than right, we will return left side plus 1. Oh, left height. I just put left height, right? Right height. Okay. Else plus 1. So if it is okay, we will get that value. Sorry. If get high, we will put the root. If the value is -1, we will say no, it is not balanced. If not, true, right? So in that case, we have, okay, now we will check the root is null. If it is null, we will return 0. If it is not null, we will get the maximum value. But in this case, if one of them is already being -1, so we don't have to do anything and we have to return just -1, right? So I will put that condition if equal -1 or equal -1. That means it is not unbalanced. It is not balanced. Okay. So let's see the result. So what about this one? It's just return false value. Oh, sorry. Oh, why I'm so confusing. Let's copy paste. Okay, cool. So let's submit this one and see the result. Okay, cool. So that's it. Thank you.